Hey everybody, we've got a new project today. It's a lathe mill drill combo, and more specifically, 1998 Smithy CB1220XL model. Uh, and it doesn't work. Uh, I got this from a friend of mine who got it from a friend of his several years ago. It's got several problems. One is that it's dirty and ugly, and the other is that the motor has been taken out of the machine and it's not clear whether it even works. So the first thing we need to do is figure out the motor, and that's where we're going today. So if you like watching a monkey monkeying around with a motor, stick around, because that's what you're going to see.
I want you all to remember that I'm just another yokel who's not educated nor a professional in what I'm doing here, and it's possible that if you rely on this video, you, your project, or the both of you might end up as a smoldering hunk of hammered dog shit. Please use common sense, be careful, and always protect your ears, eyes, face, body, and hands when doing this type of work. With that, let's keep on trucking. This video may contain peanuts.
Hey everybody, Werner here, and welcome back to Werner's Whirligigs. Today we're taking a look at a Smithy CB1220XL lathe mill drill combo. This puppy followed me home last week, for better or worse. I guess these things happen for a reason. I've been helping my buddy Greg restore an old XKE Jaguar for the past couple of years, and he's been doing it out at his friend's, who's now my friend, Jim's place. And Jim has a 2,000 or 3,000 square foot garage and also restores Jaguars. And a couple of years ago, a friend of his passed away, and this ended up in the shop, and it's just been sitting there in the corner for the past couple of years, at least since I've been there. And so before I got on the road to get out there on Friday morning, Greg texted me and he said, bring some tie-down straps. I said, well, why? And he said, just bring some. Okay. So I got out there, and about a quarter of the way into the day, Jim and I were talking, and he said, hey, why don't you take this machine home with you? And while I was flattered, I thought about it, and I initially declined. It's just because I've got so many projects and I don't even have room in my shop for this right now. We're out here on the driveway filming at the moment. But then as the day went on, I started looking through. It's got a table here that's got 4 drawers in it, and there's a cart right here that you can't see that has 3 layers, and it's well tooled. I mean, whoever ends up with this machine is going to be happy for sure. It's vices, ER32 collets, or collet chucks, indicators. That's just the beginning of what it has. So yeah, so I brought it home, and the main thing wrong with it is that the motor doesn't work. It's got a 110 volt single phase 550 watt motor, which is, I think, probably about 3/4 of a horsepower, and it sometimes turns, sometimes doesn't. So that's going to need some work. So that'll be the first thing that we get into. After that, I will spend some time cleaning up this machine, maybe using some of my magic derust solution to clean up parts that are, if they're rusty. But this is a machine I would not typically want in my shop. Nothing wrong with it. It's just, I have a full-size lathe right over there. It's a 1630, and then I've got a fairly decent mill over there as well. It's a knee mill. So, this is quite a bit smaller than what I'm accustomed to working with. But I'm sure I can find a home for it somewhere. And I think somebody would be happy to have this, especially with all the tooling. So this is going to be the project for the next couple of weeks at least. Hopefully it doesn't take up too much time, but I just couldn't let it die. I had to bring it home and need to find it a new home. So that's what I'm going to do. I cleared some spot on my workbench and brought the motor in. Label here says it's single phase AC induction motor, and 1680 RPM, 60 cycles. There's the 550 watts, 11.2 amps, and it's made in China by the Woohoo Miniature Motors factory. Interesting. Doesn't look miniature, but okay. I guess the first thing I want to do is just open this thing back up and see whether I may just want to even put a different piece of wire in here before I try to do anything. The thing that confused me a little bit is that it's got 5 wires going in. I think the other 2 are for reversing, so that's not that big of a deal, but I just I don't usually keep around 5 wire looms like this. Most of mine are 3 or 4, so I may have to be a little creative in order to at least test this out. And maybe before I even do that, one thing I've heard is that it might have some kind of a centrifugal clutch on this end. So maybe just for fun, I'll start by taking this end off and see what's under here. All right, what am I missing? What are you missing, Werner? This is not a Rubik's Cube. Okay. I was missing strength. Motor's going to have to come apart, but before I do that, why don't we test the capacitor. Before we check the start capacitor, and for that matter also the operation of the centrifugal switch, let's just quickly talk about a single-phase motor starting circuit so you'll understand why we're testing these two things. So this diagram represents a very simplified sketch of the 2 circuits in the motor. The first circuit, power comes in through L1, goes through the main windings and out through L2. And the main windings are what keeps the rotor, or the motor shaft, if you will, spinning once it's started up. Then there's a second circuit, which consists of start windings, the centrifugal switch, and the start capacitor. Now, the main windings, in most cases, can't themselves actually kick the rotor off to get it spinning. Have you ever turned on an electrical motor and it just sat there and hummed? That probably meant that the start circuit, something was wrong with the start circuit. So in this case, the start windings coupled with the start capacitor give that initial rotational magnetic pull that starts the rotor turning. And when it gets up to speed, which happens extremely fast, like 1 or 2 seconds, then the centrifugal switch, which is normally closed, so power is normally running through here at the very beginning when the motor is turned on, the centrifugal switch opens and disconnects the start windings and the start capacitor from the circuit. And then the main windings continue to do their job of spinning the rotor, spinning the motor shaft, and doing the work and the output. So we need to check the centrifugal switch and the start capacitor to make sure they are functional to know that the start circuit will be there and work when the motor needs to be started. This thing has not been hooked up to electricity in quite a bit, 3 weeks, and I know this is the wrong and hated way to discharge one of these things, but I've got rubber gloves on and a screwdriver here, so just in case. Okay. You cannot test the capacitance of a capacitor if it's connected to the circuit. Just now heating up the solder so I can remove it from the circuit. And there we go. Let's turn it off. Leave it the way it is. Okay, I want to make sure I don't forget which way it was connected. But all right, so let's turn on this multimeter that actually it can measure capacitance. Okay, and here it is. So let's see what this thing says. Okay, it says 421. And this is a 400 microfarad capacitor. I think typically it says plus or minus 5 to 10%. So 5% would be 20, 10% would be 40. So 420 would be within that 5%. It's about 5% off. Last night before I stopped, I took off the just the 3 cap screws or cap bolts on either end that hold these 2 caps on. And I peeked in here, and there is definitely a centrifugal switch in here. So this motor uses both a capacitor and a centrifugal switch to start the motor. Okay, there we go. But okay, so if we peek in here, let's see how that looks. I'm doing my best here to focus in on the centrifugal switch and the contact points. So right here, this is the contact points, and these are normally closed, meaning that they're normally in contact. And then each side has a set of wires. One is down here. You can't see right away, but and then there's this one. Well, you can barely see it. This wire coming out that run back to the capacitor. So normally the switch is closed, which means that I say normally, yeah, normally the switch is closed. And when this thing spins up, it gets a lot of speed. Then the centrifugal part is that these weights over here. There's a weight here that's working against these springs. These weights fly outwards, and the switch opens, and you can see that it's no longer open. It actually backs up against this other piece, but I don't know that that actually carries a connection anywhere. So just to test this really quick, I've got one alligator clip connected to the back side here, where this black wire is over here, and I'm going to hook a second one up over here just to test whether the currently normally closed switch is actually normally closed. So by touching this right here, as long as I get a beep, that means that the switch is making contact. Okay, so this is functioning correctly. Well, I might have jumped the gun. When I got this, I was told that the motor didn't work. I was told that the motor was taken to a friend who worked in a motor shop, and that he said he couldn't do anything with it. And I just operated off those assumptions. But, you know, and I also hooked it up to a plug and plugged it into the wall, and I got it to spin, but only at a very slow speed. It may very well be, it's probably a small chance, but that this motor is okay, or maybe there's a problem with the switches and not with the motor itself. So I went and pulled the switches off the machine, just 2 screws, and this all came out pretty much, and I can see
there's 5 wires leading to the motor here. Here's 2 of them. There's 2 more here, and finally there's a ground. And these kind of look like they've been melted or fried, and I don't know why. Something happened here. Anyway, I'm going to put the motor back together and rewire it here using the plug that came with the machine, because I can, except for the 2 browns, I can pretty much tell where the wires go. I'll have to think about the 2 browns. But maybe, yeah, I think that's the next step in troubleshooting, is just see what happens when it operates in front of me using the factory controls for it. So that's where I'm going now. I put this all back together and I wired it up the way I had it before and just plugged it into the wall to see what would happen. And it did the same thing. It turned slowly, so that gave me confidence that I'd put it back together in the right way. And then I pulled out the plug and I just put it into the next plug over for no reason, just because, and it went fast. It did the right thing. And I let it run for a few moments and I unplugged it, and I could hear the centrifugal switch kicking off after it slowed down. And then I put the plug back in and it went back to what it does, which is that's very slow turning. So anyway, after that I just wired in the factory switches here and this plug. Look at this great harness here. This feels safe. Does it look safe? Wow. Oh wow. Oh my gosh, there's actually bare, geez Louise, there's bare wire in here. Whew. Okay. The question then becomes, how do we change it? And I think what we're going to do for now is we're just going to have to cut and splice. We need a longer cord. I'll be back in a little bit. I spent a few moments cutting out the crappy burned up wire. You heard me talking before. I don't think it was too visible from the camera angle. So let me just show you what was this right here. Come on, focus. You can see it's still not really well focused. But anyway, you can see that it's bare copper showing. That's not right. So I grabbed a wire, just a whip that I had sitting around. It's a 12-3 wire, outlet wire or plug, and I'm just going to put this in here for the time being, just so I can plug it all into the wall. I also replaced the ground wire that was attached to the button box down here. That was also just basically a bunch of copper wire. Something went down though, so there was a lot of melty stuff. Okay, we're at the moment of truth. We've got the motor here. It's wired up to the button set, which is wired up to a new cord that's going into the wall. So I've got a blue button for go and a red button for stop. So let's see what happens when I do it. This is the green button start. Does not stay running. I don't know if have something on here not set correctly. If I reverse the direction, right, so real quick, right now it's going in both directions. Right now it's clockwise, counterclockwise, clockwise. If I hit reverse, counterclockwise, clockwise, clockwise. It's a new day. I've got a fresh head, and time to bring you guys up to date. I did a little bit of work off camera. I mentioned earlier that I was going to test it without a capacitor. It ran exactly the same. So I thought, well, maybe the capacitor's not doing its job. So just to double check on that, I bought a
a new capacitor. This is it. It's a 250 volt, 400 microfarad, which is about the same as the original. That one's 220 to 265, 400 microfarads. This one is from Amazon, Vexunga, made in China, of course. So I installed it on this motor here, and let's give it a shot and see. Now we're back on the same page. More of the same. Dang it. So it's spinning in both directions. It just starts in whichever direction. Probably whatever magnet it's closer to is where it gets pulled. And then it continues in that direction. But, okay, I don't have any more ideas on how to do this, how to make this work. I wish my video hadn't cut out, but there was a moment where this motor ran perfectly. It was like 1 in 100 tries. I plugged it in and it was running. So perhaps the windings are broken. There's a open circuit somewhere in there that's just infinitesimally small distance apart, and it just happened to connect that one time for some reason. So but I pulled off the end caps and looked over the windings again, and I just could not find anything. No burnt spots, nothing that looked, no melt, nothing that looked out of the ordinary. So I think I'm going to be done with this motor, and that's too bad. But sometimes that's the way it has to happen. So then what's next? Last night I was goofing around on Craigslist, and I found a couple of motors for sale by the same guy. One is a 1.5 horsepower Baldor, and he's asking $60, which is a total deal. Those things are about $800 new. And then he's got a 3/4 horsepower Marathon motor that is he's asking $40. And that both of those would be viable options for this task. But I also remembered last night that my friend had given me a motor. I knew it was like a Craftsman or a Sears Roebuck or something, so I came out, and sure enough, it's been sitting on the shelf for several years. But it is a Craftsman. It's a 1 horsepower motor. It's a power tool motor, and it's a dual voltage 115 or 230. It does not have the same footprint, but I read somewhere that the motor on those mini lathe mill combos have a slightly different footprint than most. I guess not the standard 56 frame, but that's okay. I can make an adapter bracket if I need to. So I guess let's wire this thing up and see what happens. So just for starters, I'm just going to hook it up to the outlet plug that I have. So we got white, and green, and over here I've got white, black, and green. So we'll do green to green. Okay, and then we'll take one of these whites and take it over to the white on the cord. Mind you, I've never tried this motor. My friend gave it to me. He was going to throw it away, and he's like, "Do you want it?" And I said, "Sure, I'll take it." You never know. So here we go. I've got the plug here. I'm just going to plug it into the wall. It's not even routed through the buttons, so let's see what happens. Oh, and also this thing is what speed is it rated at? 3450 RPM. This is too fast. Dang it. Well, it's yep. Let's see anyway. Shoot. Well, It's a little noisy. Got a little bit of a vibration, but it works. But yeah, unfortunately, changing the speed on a single phase induction motor is not, it's not really practically doable. If it were a three-phase motor, you could hook it up to a VFD and control the speed, but I think then even you lose some torque. Well, basically what you do is you lower the frequency of the motor, or of the electricity, the electrical current on those VFDs, variable frequency drive. You lower the frequency and that slows down the motor, but I think you lose a little bit of power or torque. I forget which. Probably both, because they're related. But on a single phase motor, no, that's not an option. It's much easier to control the speed on a DC motor than a single phase induction motor. So this one's going to have to go back on the shelf. Dang it, I didn't notice that it was 3450 until this moment. I guess I'm going to be sending an email on Craigslist. We'll follow up in a bit. We're back home. I went out to meet up with a really nice guy named Rick, who had some really cool 60s British cars in his shop. Austin Healey Bug Eye Sprite, some 3 Triumphs, and one was like a GT Fastback, and then also a Lotus. Forget what the model is now, but all of these were 60s British cars. Absolutely fun. I always meet really interesting and fun people when I go buy stuff on Craigslist. Anyways, I ended up buying both of the motors that he had for sale for $90, and so we've got 2 here. Got this Marathon. This is a 3/4 horsepower single phase reversible, and then the other one is this Baldor. This is also single phase reversible, but it's a 1.5 horsepower motor, and it weighs, boy, it seems like it weighs about twice as much as the other one. So I'm not sure which one I'm going to mount. I think I might just mount the 3/4 horsepower and keep the 1.5 horsepower motor for another project, since the 3/4 is comparable to what was in there before. Of course, it's a much larger body and frame, and it doesn't connect up directly to where it goes on the mill. And here's where it's got to sit, down in here. So I'm going to have to do some fabrication work, but that's fun. So that's where we're going next. Actually, I might test out the motors again. I already saw them run, and they run just fine, but I may have to open them up. All right, another new day, and I have a funny, not so funny story that I'll tell you while I'm sitting here and cleaning this motor, which is the original motor from the lathe. You know, I went and bought those other motors yesterday and got to meet a really nice guy, and you know, last night I was just looking at those motors and figuring out how I would be able to fit them into the lathe, because they're quite a bit bigger. And so I brought the 3/4 horsepower motor over here to my workbench, and I started to wire it into the on-off button setup here. Got it in place, tried it out, and it worked. And then just the motor itself, I didn't get into anything too fancy with it. So then I thought, okay, well, how am I going to reverse this? Because there are instructions on the motor to reverse it. But that's just a matter of switching around a couple of wires on the in the motor itself. It's, you know, but doing that with a switch requires a little more thought. And so anyways, I started looking into it, and I tried swapping around the wires on the Marathon 3/4 inch horsepower motor. Had everything set up for running it in reverse, turned it on, and lo and behold, it started running slow. just like this motor had been. And then I looked at it and there was a loose wire, and all of a sudden a light bulb went off, and I came back over to this switch and I looked, and there was a disconnected wire on the reversing switch. And so the starter coils were never actually engaged or energized. It was just trying to run off the main coils, and so that's why it wasn't getting up to speed. So as soon as I hooked everything back up to how it was supposed to be, it worked. So let's see if I can do it now. It should work just fine right now. It's actually still hooked up, just wasn't plugged in. There you go. And right now it's running, from your perspective, from the camera perspective right here, it's running clockwise. So if I reverse it, that's counterclockwise. So this falls into the category which happens often in my life, which is, this is how we learn, by, especially when trying to figure out things by ourselves. I don't have, somebody here in the shop that I can go ask. I can certainly look on the internet, but the exact question or problem that I'm having, how would anybody else know that there was a disconnected wire? So, but it does beg the question, well, why was this motor disconnected from the lathe originally, and why was I told that there was a problem with the motor, and why was it, when a motor repairman looked at the motor, he said he couldn't fix it. I don't know. We may still have issues here that I'm unaware of. But anyway, so come on, guy. I'm now moving on. I'm going to clean this motor up first. I need to make a new plastic box to cover up the electrical connections, because it was broken. And I already designed it in CAD this morning, and I just needed to come out here and get some more, get a few more measurements. And when I go back inside and have some lunch, I will finalize the drafting for the electrical box, and then I'll print out a draft. So anyways, kind of funny the way that worked out. I'm happy. I mean, I don't feel like I wasted any time. I don't regret meeting that guy Rick, who sold me the motors. I don't regret picking up two really cheap good motors. I'll use them somewhere. And yeah, I don't regret having to learn the hard way. It's the way I'm used to learning, for better or worse. And I haven't checked yet, but it's very likely that the original capacitor is just fine. So I'm going to be hooking that back up in a little bit too, just to see. Of course, I can't return this one. Well, I probably could. It's Amazon, but it doesn't feel right to me, so I'm not going to. Well, it's not perfect, but it looks better than it did before. And just in case there's any question, I'm not restoring this machine. I am not repainting this machine. I will not go through and replace bearings in this machine unless I find problems. So this is a cleanup test, and move on type of situation. There is just one small piece that is missing, and that's this number 7 rod here that holds the engine mounting bracket onto the frame of the lathe mill combo. So I found a rod that I had sitting around. Let me turn the lights back on. So there, right here, you can see the engine sitting on its mounting bracket, and that bracket has an offset or eccentric lever here that helps you remove and add tension back to the pulley that rides on the end of this motor. And I just realized I mounted the motor upside down. I'll come back to that. Anyway, yeah, so this rod that I was talking about goes in here, and I mean, thankfully, just happened to have one sitting around that was the right size. So what I'm going to have to do is cut this down and drill a couple holes in it to replace the one that should have been there. And then in each of the holes on the ends, there's a cotter pin, just so that this rod doesn't slide sideways and come out from its position in the lathe mill combo. Alright, I have the rod fixtured up now on my drill press, and just have it resting in 2 V blocks. I've already made sure that the drill bit was centered on the round. Okay, that's all I need there. May have moved a little bit, so let's make sure we're still on level. So we're not. That just means that this table isn't set up exactly 90 degrees to the bit, but that's okay. We'll just compensate for that. If you don't know this trick, you just put something flat like a metal ruler on top of the part you're about to drill, and then you move the table back and forth until it's flat, and at that point you know that the drill bit is perpendicular to the top of the rod. Simple as that. Alright, now we're going to put in our drill bit, 9/64 it is. I always try to put the chuck down in the same place I picked it up, and I forget too often. Side. All right,
Not bad. I'll go check it out and see how it fits.
Alright, I brought the motor back out to the lathe. I'm just going to start calling it lathe instead of lathe milk drill combo to mount it. And recall this rod that we made here. These fit into this bracket right here. And so that is what I'm going to do now. I'm going to pull out this cotter pin, pull this out. But yeah, then we just have to turn this around, put the motor shaft through the hole that goes into where the belt pulleys are. So what we need to do is get this rod through the bracket, through the piece that holds the motor. There we go. One more hole. There we go. Okay, and this is just a test fit, but I'll put it in anyway. Put this cotter pin in. So much easier with this set of long pliers. And the next step now, if we're running wiring, that would be the next step, but we're just going to hook it up to the machine now via this threaded sleeve. So this spins in here, and it essentially threads into there. And this is an adjuster. That's part of adjusting the belt, and then the other piece is this eccentric piece. So, if I were ready to take the belt off or the pulley, I would go like this, and it would, because the belt is back here in this compartment here, and this, in going in this direction, relieves the tension on the pulley or the belt that's riding on the pulley. So I could go do my adjustment in there, put on a new pulley or whatever, what have you, and then come back out here and let go, and then that would cause the tension to be taken up again on the belt. For the time being, I'm going to take the motor back off so I can continue cleaning up the machine. One of the last things that needs to be done on this motor before it gets mounted on the machine is to create a new electrical box. And why is it broken? It was not broken earlier in the video. I had it standing up on its end when I was looking at it one time, and it fell over on its side, and the electrical box cracked and fell apart. So my bad. Anyway, so the old one is in pieces now, but there was enough of it left that I was able to design one in CAD and make my own. So, and I'll show you in the CAD program, but I put a couple of captive nuts in here that will hold down the lid. We've got a lid here too. Goes over like this, and then these are hex screws, so they just screw in like that. Looks neat and tidy, I think. Let's take a really quick walk around the electrical box. Here it is. It's a basic square. It's got an arch along the bottom of two sides so that this can be fastened onto the side of the cylindrical motor. It's got a hole here. It's a threaded hole, and this is where the conduit goes through with the electrical wire. And this will sit around an electrical contactor that's actually on the side of the motor already. There are two screws on these corners that allow you to fasten the box to the motor, and then these two are where you attach the lid. Here's the lid. Now I could have actually drawn in threads into this thing, and I could have screwed directly into the plastic, but instead what I did was that I left some holes to insert some nuts into this piece. So we do what's called a section analysis, and I pull it down 7 millimeters. You'll see in this corner and in this corner there's a hole where I'll put the nuts into place, and then so it'll print up to this point, it will stop, I'll put the nuts in, and then it will continue to print until it fills up to the top, and those nuts will be inside the part for the life of the part. And those nuts will be there so that the screws that hold the lid on have a place to anchor. And then, okay, we've got to run this out. And I'm going to come back and rewire this with the good wires a little bit later, but for now I'm just leaving the old ones in place so I don't forget where everything goes. It's just a lot easier than even taking a picture. But this is how it's going to sit. And the last thing is that there is this threaded grommet thing that also goes over the wire. So you can see that this just screws in. So that's part of the original box, but I just made I designed it so that it had that with the female thread, so then it just goes on there. And then I'll have to take this screw off here, and I might as well do it, and screw it down. So let's do that. Okay, and then the lid goes on. And then finally, this is going to go on. This is the adjuster. All right, and here's so we have the eccentric here, and then this is the adjuster. So now that we're done with that, this motor is ready to rock when I add new wiring on. And that's going to pretty much wrap this up. Well, that was fun and tedious and frustrating and challenging, and maybe a few expletives that I won't say now, but the motor works now, and that's good. You know, I felt like that was what my friend Alan calls an effort in brute force learning. You know, that's where you lose your grace. You're not suave anymore, and you just keep pounding away at a solution until you find it. And that's what it felt like to me. Not having a wiring diagram for this motor made it really confusing for me, especially with these extra 2 wires on the pigtail. Uh, I've only worked with single-phase motors that moved in one direction. I've just never had to work with a reversible motor before, and I didn't understand why there would be extra wires coming in here, out here. I had a feeling they were part of the reverse mechanism, but even then, I didn't understand how they were to be connected up. I didn't realize that. I thought maybe they were just signal wires, but no, they're actually carrying 110 volts just like the other wires, and they are part of getting this motor running and going. So, but as I like to say, one learns by doing. If nobody's here to tell me how to do it, I've got to figure it out for myself, and that's what we did. So thanks for sticking around. If you've made it this far, perhaps you enjoyed what you saw. Uh, Give me a thumbs up if you would, if you liked it. That doesn't cost you anything. Or feel free to subscribe. I'm putting out videos on the 1st, 21st, and the 11th. The 1st, the 11th, and the 21st of each month. So that's roughly every 10 days. And if you want to know when the next one is, subscribe, and you'll get a notification so long as you, I think you have to hit the alarm button or something. I don't even know. I subscribe to a bunch of things, but I don't get alarms. All right. Well, it's a pleasure. Thank you. See you next time. So long for now.